All right, I need to go to a new page here. All right, how about this? Part C. We want to know the intervals of concavity and want to know the inflection points. All we do for part C is exactly what we did for part B, or A and B, except we work on the second derivative, not the first derivative. So what would the second derivative be? Say it. 12x plus 6, that's it? Everyone agree with that? What I want to know again now is where's the second derivative equals 0 and where's the second derivative not exist? Well, as before, the second derivative not existing we don't have to worry about because it's nice. The second derivative being 0 is a linear equation. I don't know why I put 16. That is x equals what? 1/2? Negative 1/2, thank you. Seeing if y'all are awake or not. So I have to write things down incorrectly to get y'all to respond. That'll work. We can do that. What now? If we plug negative 1/2 back into the derivative, it'll give us 0, right? What did we do? What did we do with the previous problem? Once we figured out those numbers, what did I do? I did a number line. Okay, that's what we'll do again. Number line. I put negative 1/2 here. That's going to split my number line into 2 regions. And now I'm going to pick 2 test points. One to the left, one to the right. What's a good number to the left of negative 1/2? Negative 1? What's a good number to the right of negative 1/2? 0 or 1 or 2 or 3 or pi or e. Doesn't matter, any number, right? But try and pick something that you think is going to be easy to plug in. Now, where am I going to plug these in? Into the second derivative. Because remember, second derivative tells you if you're smiling or frowning. So what's the second derivative at negative 1? Well, that's 12 times negative 1 plus 6. That's negative 6. That's less than 0. Right? What does it mean if my second derivative is less than 0? What is my original function going to be doing there? What is it going to be doing? Not decreasing. Concave down. So it's frowning, isn't it? So I'm going to put a frown like this. If you even want, you could, put in a little face there. You don't have to, but it's an option. Now I'm going to test the second one. The second derivative at 0, plug in 0, you get 6. That's positive, right? What does that tell me? If the second derivative is positive, that tells me the original function is concave up. Happy, right? So, if you're taking anything away from this, the first derivative tells you where you go up and down. The second derivative tells you where you're smiling and frowning. That's it. So let's answer part C. For part C, where is f this? Now, I'm going to use that to mean concave up, everyone. All right? Instead of writing the words concave up. Where is f concave up? Where does it start? Negative 1/2 to forever, right? Where is the original function frowning? Negative infinity to negative 1/2, right? Where are there inflection points? There's only one, right? X equals negative 1/2. Now, as we did before, I'd like to now figure out, well, what's the function's value at negative 1/2? So go back and plug negative 1/2 into the original function. Original function, right? Anyone have it yet? Anyone have? Anyone? Anyone? What'd you get? Negative 63 over 2? Anyone else got that? Negative 17? Anyone else? I'm looking for 2 people to confirm the answer. Negative what? Please, not all at one time. Raise your hand. Where are we plugging this into? 2x cubed plus 3x squared, right? Okay, so 2 times negative 1/2 cubed plus 3 times negative 1/2 squared minus 36 times negative 1/2, right? That's... What do you got? 18.5? 18.5? That's what I got too. So that means as a point, it's negative 1/2, 18.5. 18.5. You could put negative 0.5. Now, Myra, I heard you. What did you say about your calculator? Can't you just what? Sure. To evaluate it? Yeah. But that plugging a value into a function is a skill that's way, way back, right? So however you do it now is fine. Okay? Are there any questions on this? I think we've answered everything. What I would like to do, though, is what I've done before and try and just look at the graph of this real quick. Myra, you bring in a very good kind of question, something that we can talk about. Technology is to a point where it can do a lot of calculus for us, So there's this big debate, why teach all this stuff if, you can just have a computer answer all these questions? And that's a really good argument, What do you all think? This is the graph right here. We've had some, here we go. Let me try. Remember last time we did this? This sucked. Let's try it again. 10. 10. I don't know why it didn't work last time. What was our maximum? Was it 81 or something like that? So I'll make it 90. Okay. I think we can kind of tell from this, can't you? That our function, where is our function going up? All the way till we get to some value here, some x value, right? Then it goes down for a while, and then it comes back up. We can see that the local maximum occurred at, what did we get? Negative what? Where did the maximum occur? Negative 3? Yes? And the minimum occurred where? At 2, right here. Where's our inflection point? Negative 1/2, 18. Right about here is where our inflection point is. Kind of matches up, right? To the left of that arrow, frown. To the right of the arrow, it's a smile. Yeah? Okay. Do you think with what I've given you, you can handle a quiz? You can try at least? Well, I'm going to give you two problems. The first one is going to be a nice polynomial. The second, well, I'm going to give you three. The first one's going to be a polynomial. The second one's going to be a rational function. The third one's going to be a trig function. So I want you to do at least two of these, all right? I'm only giving you three in case I've got to go run and meet with the math department real quick because I was supposed to go to a meeting this morning and I missed it. And so I'm going to run over there, let y'all do an in-class quiz. It's supposed to be like 15, 20 minutes. I'll be back, okay? Help each other out, though. I mean, this is an opportunity to get 100 as long as you can make it happen. Okay, so let's just put on here quiz. You will turn this in. Put today's date. All right, the first problem. It's the same instructions as the ones we just did, okay? F of x equals 4x cubed plus 3x squared minus 6x plus 1. Second one, f of x equals x over x squared plus 1. And the third one, f of x equals sine x plus cosine x on the interval 0 to pi. Now let me say something about number 3. On number 3, I'm not asking you for absolute max and min. I'm asking you for all the local maximums and minimums. All right? So follow the process that I just went through today for all of those problems. Don't revert back to what we did in 4.1 for number 3. Okay? You think you can handle that? All right. Good luck. If you finish before I'm back, just take a break. All right. I wanted to show you on the quiz number 2 that everyone's working on, that x over x squared plus 1. This is the graph of that function. And I just wanted to point out, first of all, the max and min. You have one max right here. It happens, it looks like at 1, what, 1/2? At 1, 1/2. That's your local max. And then, let's see, the next one was at -1, -1/2. So you can tell by the graph, that's your local min and local max, right? And then you should have 3 inflection points. There's one right here. You can't really tell, but this is a frown turning into a smile. Smile, smile, smile. Then comes frown, frown, and then this is the bottom part of a smile. So, again, just to verify what the algebra returns to us. Okay? All right, I want to do another problem like this. I'm going to work pretty quick through it, though. Let's look at, where is it? F of x equals cosine squared x minus 2 sine x on the interval 2 pi, so or 0 to pi. So this will help you with that third quiz problem. All right, first derivative is -2 cosine x sine x minus 2 cosine x. So what I had to do here, remember on cosine squared x, that's chain rule, isn't it? right? Something squared. What's the derivative of something squared? 2 times that something times the derivative of something which was negative sine x. Right? So the yellow highlighted, the derivative of the yellow is the red, right? And then I just move the negative out front. And then the derivative of negative 2 sine x is negative 2 cosine x. So any questions on that? Good? All right. So what are you supposed to do with this now? Set it to 0, right? So when I take